Let g of t equals cosecant of t. We want to discuss its domain. Cosecant of t is the reciprocal of sine of t. And the domain of g of t is the set of t. T can be any real number except sine of t cannot equal to 0. Otherwise, the denominator will be 0, and we will have dividing 1 by a 0 number. If we draw the x and y axes, sine of t will represent by the y value. Sine of t equals 0 when y equals 0. And that happens when the angle in standard position is equal to 0, or pi, or 2 pi, or 3 pi, and so on. Thus, the domain equals the set of t such that t cannot equal to k pi, where k is any integer. We draw a number line to see how this works. It can be any real number except when t equals 0. That happens when k is the integer 0. When k equals 1, t equals pi. When k equals negative 1, t equals negative pi, and so on. So what happens is that when we have k times pi, there is a hole there, and then the next hole will be k plus 1 in parentheses times pi. We use the extended interval notation to write down the domain. It equals a big union sign from k equals negative infinity to infinity. K can be any integers. We write down a set of parentheses, k pi, comma, the sum, k plus 1 times pi. That's our domain.